When an object is immersed in a fluid, the fluid applies force on every surface of the object. This is fluid pressure, and it varies depending on depth. The deeper the object is in the fluid, the greater the pressure. This explains why the part of the object that is deeply immersed in the fluid experiences more pressure than the part of the object that is less deeply immersed. In other words, the forces applied to the base of the object are greater than the forces applied to the top. The forces on each side of the object balance each other out, which is not the case for the forces applied to the base or to the top of the object. The resultant force, called buoyant force, is therefore the force exerted by a fluid on an immersed or partially immersed object. According to Archimedes' principle, the magnitude of the buoyant force, Fp, is equal to the weight of the fluid displaced by the object in newtons. Once an object is immersed in fluid, the object occupies the space of part of the fluid. A volume of fluid that is equal to the volume of the immersed object is displaced upward towards the surface. The weight of the displaced fluid corresponds to the buoyant force. For example, if the immersion of a cylinder in water displaces a volume of water with the weight of 10 newtons towards the surface, the buoyant force applied to the cylinder is also 10 newtons directed upward. The comparison between the buoyant force and the weight of an immersed object determines if the object will float, sink, or maintain its depth in the fluid. If the buoyant force of the fluid is greater than the weight of the object floats. If the buoyant force of the fluid is less than the weight of the object sinks. Finally, if the buoyant force of the fluid is equal to the weight of the object maintains its depth in the fluid. In summary, to know if an object will have a tendency to float, sink, or maintain its depth in a fluid, it's important to know both the weight of the object and the weight of the displaced fluid. In other words, the buoyant force.